Okay, so if you're asking what are Cartesian coordinates of a 3D system, you can see we have Z, Y, X. This is just an example. We have A1, A2, A3. It was actually to be supposed to be AX, AY, AZ. But anyway, it's fine. So it's that point that you see there. Okay, so that point you see there is actually this point. So it starts here. So this is where we have our AX, and here this is where we have AY, and here this is where we got our AZ. Okay, just to give you an idea of how we're able to present this. So now to find the resultant vector, so this is a symbol of vector, it will be AXI plus AYJ plus AZK. So this is what you see. It's the same as this formula. So instead we call it A1, A2, A3. Okay, so that's what you see. We got our resultant vector. Okay, and if for example we add before two angles, two vectors. So if it was two vectors, this is how you could represent it. In case it was two vectors, so to be A plus B in terms of Y, I, A plus B in terms of J, A plus B in terms of K. Remember the previous example where I showed you where you can add two vectors. Okay, so and then scaling, this is what we call scaling. Scaling is when you take, maybe K is a constant, you can take a constant times everything inside the vector equation. So the resultant equation, you can see K times A vector, K times A1 I, K times AZ J plus K times A3 K. So that's what you see. This is what we call scalar. So this is what we call scalar. And that K could be a number, 0, 1, 2, 3, 4, 5, depending on what you have, or a negative 2, negative 3. Okay, and this one was just to show you the addition of two vectors. Okay, the addition of two types of two vectors, and then this is how you represent the magnitude. If you have to find the magnitude of this equation, this is how you're going to find. So to be the resultant inside, so it will be A1 square, which is AX, A2 square, which is AY square, A3 square, or not square, to the power of 2, which is AZ. So this is how you find your magnitude. Okay, let's see some more example. What about the displacement of a vector? Okay, so displacement of a vector, it's where we have an example of a negative sign. Remember, if you look to this graph, we have R1 and then we got R2. So R1 and R2, the resultant equal to, so it's the resultant of R1 and the resultant of R2 equal to R2 negative R1. So that's what you get here. Okay, and in order to represent them, the resultant of R2, it will be everything that you see in X. So everything that you see in I square, I vector, R unit vector, J unit vector, K unit vector. So you just negative them. but you consider the second one as x2. So what you see here, we had something like this. Okay, this is what we got. This is r. Okay, and then when it's come to r1, for example, the way that you're going to represent it will be, you represent it this way: y1 j. This is how you have to represent this the r1. This is how you do represent r1. And then if it was r2, r was going to represent r2 like this, plus y2 plus z1. It's actually z2. So you're going to take this one and that one together, this one and this one together, and that one together. That's how you're going to end up. So it's going to be x2. So since it will be r2 negative r1, so this vector. Okay, so it will be x2 negative x1. That's what you see here. y2 negative y1, this is what you see there. z2 negative z1, this is what you will get there. So this is what you see on the displacement vectors.